As we continue in 10.4, this video is going to take a closer look at distinguishing between two types of tangent circles. Tangent circles touch at exactly one point. In a plane, two circles can intersect in two places, one place, or not at all. If they intersect at one place, they are considered to be tangent. If one circle is inside the other, then they are said to be internally tangent. If one circle is outside of the other, then they are said to be externally tangent. So, concentric circles with radii of 40 and 41 have a center P. Chord XY is tangent to the inner circle and is the chord of the outer circle. Find XY. Well, the first thing I would need to do is a drawing if one were not provided. Fortunately, here it is. So I would draw two concentric circles, and then a radius, and then a perpendicular chord. Because if a radius is drawn to a chord at the point of tangency, then we know it is perpendicular. Now, I was told that the radii are 40 and 41. So the smaller number goes on the inner circle, and then the bigger number goes on the outer circle. Now, if you didn't recognize this as the Pythagorean triple, 9, 40, 41, then you would have to do the Pythagorean theorem so that you would say that xc squared plus 40 squared equals 41 squared, and then solve for xz. But I know it's the triple, and to expedite this, I'm just going to label that 9. I also know if a radius is drawn perpendicular to a chord, then it bisects the chord, so that zy is also 9, which makes xz 18. Concentric circles with radii 48 and 50 have center at P. XY is tangent to the inner circle and is the chord of the outer circle. Find XY. I encourage you to pause the video and try this one on your own. Begin with a drawing. Draw in the larger circle's radius. Recall that the smaller circle the radius is going to be perpendicular to the chord because they connect at the point of tangency. And then the smaller number goes on the smaller radius. The larger number goes on the larger radius. So I have xz, 48, and 50. I can factor a 2 out of there. And then I have whatever that side is, 24, 25. Again, that's a triple, where a is 7. Therefore, xz is 14, which makes xy 28. Pause and try this one. The radius of the smaller circle is 3. The radius of the larger circle is 4. I don't know the length of this side here. So I have a, 3, 4. That's not a triple, but I can use the Pythagorean theorem. Therefore, xy is equal to 2 times the square root of 7. They won't always be triples. You have to sometimes use the Pythagorean theorem. You may also see these problems in the context of coordinate geometry, which is just simply where you have points given to you on the x and y plane. Two concentric circles share center A, so that means this circle and the outer big circle share center A. Circle B and the larger circle A are tangent internally, and the larger circle A has a diameter of 8, which would make point C 8, 0. Then we know the radius is going to be half that, which means point A is 4, 0. And then OA is a diameter of the smaller circle, so that makes point B 2, 0. Circle B is congruent to the smaller circle A. Find points B and D. So this is congruent to that, is congruent to that. So now we have 2, 4, 6. That would make point D 6, 0. Yesterday, we took a look at this exact drawing here, and we know that if we draw a radius to a point of tangency, that it forms a right angle. We also know that any segment is congruent to itself, and that all radii of the same circle are congruent. Therefore, by HL, we have PR congruent to PQ. That proves that if two tangent segments are drawn to a circle from an external point, then those segments are congruent. Looking at that in an algebraic context, we know that AB and AD are tangent to circle C at points B and D. Therefore, these two segments are congruent. So I can say 7x minus 2 equals 3x plus 8. Subtract 3x from both sides. Add 2 to both sides. And reduce. Pause the video here and try this one on your own. Given the diagram below, if 2 of the 5 points shown are selected at random, what is the probability that they are the endpoints of the larger circle's radius? Our textbook has been encouraging us to write a list. So we could have PX, PY, PZ. I chose to organize them alphabetically. XY, XZ, or YZ. So there are 6 total possible outcomes. In terms of which would actually be radii of the larger circle, PX and PY, so that's 2 out of the 6, or 1/3.